Okay, good morning everyone. The previous competition we received, can't remember now, but roughly 70 proposals, 62 proposals, and from that we selected 10 for the final presentations, and from these 10, this was the first one that received the first prize. And the reason for this one to be selected is basically it satisfied all the criteria and it excelled on many of the criteria that was put down as minimum requirements, so to speak. I think if we roughly look back at the criteria for those of you that can't remember, it was you have it somewhere. Originality was the first. 20% of the marks went to originality. 50 points. I think this is the new.
Yeah, this is a new one.
This is a new one. Okay, but it doesn't matter. But 20% of the marks went to originality. So it means it must be a new idea, a novel idea, hasn't been done before. And some of the proposals presented good ideas, but it was implemented before. So on that mark, it scored low, although it was a good idea. So originality was very important. The next one was sustainability, meaning that this mission must be continuous. It must be the satellites afterwards, the first satellites deorbited or came to the end of life, you had to replace it to continue the mission. So if you propose, for example, a science mission with one goal to satisfy, and you can satisfy that goal in a year or 2 years in orbit, and then after that it's over, that means it's not really a sustainable mission. So it had to be sustainable. 15% of the marks was for sustainability. And then the other important one is impact on society. So many of the scientific missions that was proposed was good for the scientists, but maybe not good for the man in the street, so to speak. So it must add a big benefit for the average man in the street as well. And this is where the first paper scored very high marks, because it combined meteorological weather type application with precise positioning. We all use GPS to travel around nowadays, so it combined two aspects that a man in the street really uses on a daily basis. 15 marks also for that, so that gave you the 50 marks for originality. You can, this is a total different. Can we just move away from this, otherwise it will be a bit confusing. Impact on society, I've said that. And then technical feasibility. So we had many proposals, especially from maybe countries that's not really active in space. That's good proposals from the first 3 points of view. It was original, it had a good impact on society, but it was not really technically feasible, especially on a small satellite constellation. You cannot propose something that requires an imager system with an aperture for the telescope of 1 or 2 meters, because you want to see centimeter resolution on the ground. So it's not technically feasible. The other application I can remember was to have a low Earth orbiting satellite, 200 kilometers or 100 kilometers altitude, and okay, that cannot work. The drag will just kill the mission within a couple of hours. Or the other application I can remember proposed to monitor traffic in a big city. It's as if the proposer thought that you can implement a geostationary satellite from 200 or 300 kilometers. Okay, so that's also not technically feasible. So it's just impossible. So maybe it was an undergraduate group of people that proposed that haven't done orbital dynamics or a great deal of satellite engineering before. Then we had proposals for scientific missions that is only feasible maybe on a 400, 500 kilogram satellite, definitely not on a small, less than 50 kilo satellite, because the instruments that you had to carry on your satellite mission is way too big for that mission. The technology doesn't currently exist to miniaturize, for example, your payloads to such a size that it can fly on a 15 kilogram mission. So 20 marks was for technical feasibility, and then the other two requirements was to look at the programmatic design of your mission. How are you going to put this mission together, and the schedule for that, in what is the timeline of the mission, and many of the proposals just ignored that point. They didn't look at that at all. And finally, operational. Once the satellite is in orbit, or the satellites are in orbit, how are you going to control the mission? What is your ground segment going to look like? You also have to look at that, not only the space aspect. 50 marks for that, and that gave us the total of 100 marks. So we went and looked at all the proposals strictly according to these schedule or rubric to assign marks to the different parts of a proposal. Okay, so if we look at the first place, this integrated meteorological and precise positioning mission, so that really combined two aspects, making this mission definitely of great impact on society, what it was supposed to do. It was a novel mission. I don't know of any mission like this that flew before or is currently in orbit. There was clear objectives put forward in the paper, so that's also important that you set your objectives, what this mission is trying to accomplish in your paper. The key performance parameters is the important thing, to say what is the key performance parameters for this specific mission. What is the orbital parameters? What is the power budget? What instrument on your satellite do you require or do you need to satisfy the goals? So key performance parameters must be listed in some way. Okay, and then from a technical point of view, it will be good to do a mass and a power budget. Do the design to such an extent that you have a table at least listing all the mass components in your, or listing all the components in your satellite and the mass of the components, and add it up, and you must then come within the 15 kilogram limit for the next mission within the 50 kilogram limit. So you must convince the reviewers that you have looked at all the technical detail, although you don't need to put it in your paper because the paper is limited in length. You cannot do a detailed design, but at least you should have thought of most of the detail. And you can summarize that as efficiently as you can in a graph or in a table. It will be a good idea. Draw a system block diagram. Most of the proposals don't even add a system block diagram, so it was very difficult just by reading words to understand how this mission is going to be put together and be implemented. Do a link budget if you can, so that you can make sure, especially if communication is a great part of this mission, to make sure that it is feasible, that you can communicate inter-satellite or satellite to ground station. So your link budget has been looked at. Do the orbit design. Don't come up with impossible type of orbits. So it must be feasible, must be doable. The life of the satellites must correspond to the orbital altitude. It's no use to design a 200 or 300 kilometer altitude for a 10-year mission without any propellant or propulsion system, for example. Your implementation plan. Do the implementation plan. It can be one paragraph, but at least it must be there. You must be able to see that there is an implementation plan and a project schedule with a timeline to show that it is feasible to do it I think in the previous competition, it stated that it must be less than 2 years, the total development time. I'm not sure in this next competition whether there's also a development time limit. And in the previous competition, there was also a cost limit, less than $6 million, excluding the launch. So if you propose 1,000 satellites and you want to do that less than $6 million, you have to prove that it's feasible. Your satellites will be low enough cost that you can do it within the budget that's available. Right, so I think the first prize went to a proposal that satisfied all the criteria to an excellent extent, especially the novelty of that. Technically, it was a very strong proposal, well thought through. You could see that maybe this mission was planned not only for the competition, but before the competition they already worked on this mission. But you cannot penalize them for that. So they had an advantage as well. They work in the space environment, so they knew what they were doing. The second prize went to a disaster management constellation of small satellites. That was just one person, but that person also worked in the space industry in a mission analysis group. So he knows how to put together a mission like this that he proposed. And for that mission,